Assalamualaikum warahmatullahi wabarakatuh. So today I'll be presenting on this topic, Kangkong leaf extracts as natural therapeutic agents for the EREKA competitions. So our teams consist of Dr. Amirul Rizwan Berwaka, Ahmad Mukhlis Abdul Rahman, Ryan Vitaya Peron, Muhammad Khalid Kasim, Ahmad Saiful Salim, Nurul Husna Khairuddin, and Ahmad Zahari Nur. So basically the research background for this particular research is that we implement the usage of Kangkong, Eprema aquatica, the scientific name, that are widely cultivated and can be found growing wild in the aquatic or semi-aquatic habitats in Perlis. So, situated on the northern border with Thailand, the benefits of tropical climates and the proximity to water bodies, for example, the rivers, the pond, the paddy fields, these create a favorable environment for the kangkong or water spinach growth. And the kangkong or water spinach is a popular delicacy or vegetables in Malaysian cuisine and is likely grown in Perlis for local consumptions or for commercialized purposes. And it is commonly used in various dishes such as the stir fries, soups, salads, and these contribute to the Perlis culinary diversity. However, as water spinach naturally grows in waterlogged areas such as the riverbanks, effort to control its growth can be aligned with utilizing it as medicinal properties or medicinal active pharmaceutical ingredients. Our approach in this study is to resolve the issue of water spinach potentially becoming invasive and disrupting native plant species is by converting it and exploit its potentials to become as an active pharmaceutical agent. Thus, by converting water spinach or kangkong into an active pharmaceutical agents, we can not only address its invasiveness, but also harness its potential, its medicinal benefits to develop it becoming valuable pharmaceutical products. And the idea behind this approach not only mitigates the environmental impact of water spinach, but also transform it into valuable resources for healthcare, nutraceutical, and pharmaceutical industries. Hence, through these sustainable management practices, we can simultaneously protect native plant species while utilizing the biodiversity enhancing property of water spinach for these medicinal purposes. So these are the material and the method used for these studies. First, we collect the kangkong from police, and then we determine the foreign matter and microscopic analysis, and then we prepare kangkong material and conduct the color test. After that, we conducted the quality control analysis of kangkong, and we conducted extractions using the maceration technique and the ultrasound assisted extraction for the kangkong. After that, we quantitatively determine the total flavonoid content, the total phenolic content, and the total protein content of the kangkong. Then we fingerprint the profile of kangkong using the FTIR and UV. And lastly, we conducted antioxidant and antimicrobial property testing. So the research finding for the quality control, we found out that the raw material used for these studies are within the immaculate conditions, meaning that these raw materials are as clean as possible that are needed for it to become a medicinal agent. So the total ash that determined the cleanliness was shown to be 13.11% that indicate it is within the acceptable range. And the acid insoluble as 4.6% was also within the acceptable limits as per proposed by the British Pharmacopoeia. On the other hand, the total moisture content is approximately 5.6%, which is lower than the limit. This indicates that it is within the good quality and it will reduce the risk of contamination since these microorganisms are opportunistic, so meaning that they prefer high water content to grow. So in a nutshell, this result suggests that these Kangkong or aquatica leaf have the potential to be developed further as herbal products. For the extraction yields, so there are two types of approaches used for the extraction process. The first is the ultrasound assisted extractions and the macerations. So for both of these techniques, we conducted it using three different solvents, which is 100% methanol, 100% ethanol, and 100% water. So the result from the extraction yield showed that the kangkong leaf in methanol and the solvent have the highest yield of 13.98% in macerations and 17.55% in the ultrasound-assisted extractions. And this was significantly greater compared to the water and ethanol extracts that yielded 12.88% and 9.25% respectively in macerations and 13.93% and 14.55% respectively in the UAE. For the preliminary phytochemical testing, the color tests used are to determine the glycosides, the alkaloids, the flavonoids, tannin, and the anthraquinones. So the reagent used that will react with the raw materials are the sulfuric acid, hydrochloric acid, sodium hydroxide with hydrochloric acid, ferrum chloride, as well as monohydroxides. So from the finding, we found out that Eponema aquatica contains all of these groups. The glycosides, you have the alkaloids, you have the flavonoids, the tannin, as well as the anthraquinone. Next, we conducted quantitative phytochemical testing analysis. For the total protein content, the primary metabolite, we found that the highest total protein content in macerations was in the ethanol extracts. The value was 0.38082% milligram per 100 ml of bovine serum albumin equivalent. And for the ultrasound assisted extractions, methanol extracts had the highest protein content. So specifically, methanol extract yielded 0.3082% milligram per 100 milligram in macerations and 0.3092% milligram per 100 milligram in UAE. This concluded that the macerations generally resulted in higher protein contents compared to the UAE technique. For the phenolic content, the highest was in the maceration extracts, with methanol extract showing the superior value of 14.43 milligram per gram of gallic acid equivalents. In the UAE extracts, the methanol extracts also had the highest phenolic content with a value of 12.35 milligram over grams gallic acid equivalents, and ethanol extracts was 10.32 milligram over gram in maceration and 9.8386 milligram per gram in the UAE. So overall, the water extract had the lowest phenolic content in both methods, and we can conclude that methanol was the most effective solvent for extracting phenolic compound with high content observed compared to ethanol water extracts. For the total flavonoid contents, overall, the macerations in maceration technique, the ethanol extract had the highest flavonoid content with the value of 5.32 milligram over grams quercetin equivalents, then followed by methanol extract with 3.81 milligram per gram, and lastly water extract with 0.97 milligram per gram. And this suggests that the ethanol was the effective solvent for extracting flavonoid in the macerations. Whereas for the UAE, ethanol extract showed the highest flavonoid contents. The value was 5.9 milligram over gram, followed by methanol extracts of 4.72 milligram per grams, and water with the lowest flavonoid content. the value was 1.24 milligram per grams. And this reinforced ethanol's suitability as a solvent for flavonoid extraction in the UAE. So the lower flavonoid content in water extract can be attributed to the polarity of water, which is higher than ethanol and methanols. And since most flavonoids have different polarities, so water lower polarity may result in lower flavonoid yields, indicating a higher percent of non-polar flavonoid in the Epoderma aquatica leaf extracts. So next, we conducted the phytochemical testing using several instruments. First is the UV analysis. So the UV analysis for all the extracts shows that they peak on the 300 nanometers to the 400 nanometers. So this indicate the polyphenol groups as well as the flavonoids, especially on the uh, hydroxy groups. Okay? And for the 600 to the 700, it shows a significant peak there, and these indicate the chlorophyll derivative, which are common in leaf extracts. And for the FTI analysis, the peak here suggested that the elements represents the fundamentals functional groups of phenolic compounds and flavonoid backbones. So this indicate and confirm the presence of both polyphenol and flavonoids in the extracts. Then we choose the best extracts and we conducted the therapeutic activities. The best was the methanol extracts or ethanol extracts. And for the DPPH assay, methanolic and ethanol extracts demonstrate potent antioxidant properties, which the methanol extracts exhibit higher radical scavenging activities with the IC50 value of 152.742 microgram per mil compared to the ethanol extracts, which the IC50 values of 194.716 milligram per mil. And this suggests that methanol is preferable solvent for extracting antioxidant agents like phenolic acids, polyphenol, flavonoid, etc. So the results align with the analyzed flavonoid and phenolic content, indicate their roles in radical scavenging activities. Additionally, we conducted also antimicrobial tests, and the test organism used was the E. coli. So the positive control for the study is amoxicillin, and the negative control was the distilled water. The tested sample was the methanol extracts and the anethanol extracts. Overall, the highest inhibition was in the positive controls and followed by the methanol extracts with 8.5 millimeter of inhibition zones. So this also confirmed that the polyphenols, the flavonoid, and etc. available in methanols contribute into the inhibitions of E. coli. So the outcome of the studies. So in the studies, Epoderma aquatica underwent rigorous testing to assess its potential as medicinal plant, and the quality control and chemical profile analysis revealed its suitability for commercialization in herbal medicines. And overall, the highest total protein was obtained through macerations with ethanol as a solvent, while methanol was preferred for the UAE. Both methods yielded a significant phenolic content, with methanol being the most effective. Ethanol extracts, on the other hand, showed the highest yield of flavonoid content. Additionally, methanol and the ethanol extracts exhibited notable antimicrobial and antioxidant properties. This is attributed to the presence of flavonoid and phenolics. And the UVVs and as well as the FDI analysis also confirmed the presence of flavon or flavonols supporting the previous findings. And FDI also identified various phytochemicals with no toxic component detected. Hence, Epoderma aquatica show promises for herbal medicine development and is considered safe for consumption. So for the conclusion, we managed to create an Epoderma aquatica or Kangkong leaf extract with high polyphenol content and noticeable antioxidant and antimicrobial properties. And these can be a natural agents to combat free radicals as well as to inhibit microbes, especially the E. coli. So these are the LOI with Visol, which is a herbal company, and the references within that. I thank you guys for listening to this presentation.